Now I'm going to show you guys how we can compare fractions without modeling fractions. Okay, so in your notes, there are two steps. The first step for comparing fractions is to make equivalent fractions with common denominators. So you guys need to write that step down. This is step one for comparing fractions. Make equivalent fractions with common denominators. Write that down. This is really going to help you, this step, when we get to adding and subtracting, because this is the first step with adding and subtracting fractions as well. Your second step for comparing fractions is you compare. You can just write that down. You look at your numerators, whichever one is bigger is the bigger fraction. If you think about a pizza, okay, think about a pizza with 10 pieces. Is 3 pieces of that pizza or 4 pieces of that pizza bigger? 4. Okay, so that means 3 over 10 and 4 over 10 as fractions. 4/10 would be the bigger fraction. That's what we're doing here. Okay, we're creating the same amount of pieces in a pizza, and then we're going to figure out which one has the most pieces. That's what we're going to do with two different fractions. But in order to do that, we need to make an equivalent denominator. Okay, we need to make sure that our pieces are the same in each pizza. So write this down as your first example, 1/3 and 1/4. So now instead of doing GCF, which is what we use to simplify the fractions, we need to think about our LCM, our least common multiple. What's the least common multiple? So this is the smallest number that both 3 and 4 can go into evenly. What is that number? Jamie? What's the smallest number that both 3 and 4 can divide into evenly? No, 1 can go into both of those. That would be your GCF. I want to know the least common multiple. What do you think? We did this. What's the least common multiple? Remember I taught you guys the ladder method? Can I pull anything out of 3 and 4? No, so what do I do with these two numbers to find the least common multiple? You multiply them. What's 3 times 4? 12. So our least common multiple between 3 and 4 is 12. Is that coming back to us a little bit? Okay. So what we need to do to make equivalent fractions, we need to make the denominators equal to 12. So our denominator over here has to equal 12, and our denominator over here has to equal 12. Well, how did we change 3 to equal 12? Taylor? Yeah, we multiplied it by 4. But in order to make an equivalent fraction, whatever you do to your denominator, you also have to do to your numerator, right? So we need to multiply 1 times 4, which is what? 4. So our equivalent fraction is 4 over 12. Is everybody okay with how I got that? Over here, we still need 12 in our denominator, but how does 4 become 12? Victoria? Yeah, we have to multiply this one by 3. Whatever you do to your denominator, you have to do to your numerator. And we get 3 over 12. So now we have to look at our equivalent fractions that we just made, and we can compare these. Which one's bigger? 4 over 12. If I had a pizza with 12 pieces, is 4 pieces bigger or is 3 pieces bigger? 4. So we need to put the correct symbol in here. So am I going to put a greater than, a less than, or an equal to symbol? I'm going to put a greater than. I want to read this as 4 over 12 is greater than 3 over 12. If these were flipped around, then I would have to say 3 over 12 is less than 4 over 12. And then if your numerators were equal, if they both said 4, it would say 4 over 12 equals 3 over 12. Okay? Let's move on and do some examples together. So I put the steps up there just in case you didn't get them written down yet. So the first one, we need to make equivalent fractions. What's the smallest number that both 2 and 4 can go into evenly? Victoria? It's 4. If we did the ladder method with 2 and 4, what can we pull out?
2.
A 2. And we're left with 1 and 2. And remember, with the ladder method, you make your L and you multiply. What's 2 times 1?
2.
What's 2 times 2?
4.
4. So do I have to change this fraction?
No.
No, it already has 4 in the denominator. So how do I change this 2 to become 4? Taylor? Yeah, we have to multiply both your numerator and denominator by 2. So this becomes 2 over 4. So now which one's bigger, 2 over 4 or 1 over 4?
2 over 4.
So which symbol am I going to put in here?
2 over 4.
Which symbol? Greater than.
Oh.
Okay? Write this next one down with me. 6 over 8 and 1. Well, if this is 1 and the whole thing is shaded in, what's my part over whole? What part is shaded in? 1 out of how many pieces? 1. So to write 1 as a fraction, it becomes 1 over 1, right? What's my least common multiple of 1 and 8? What's the smallest number that both 8 and 1 can go into?
1.
No, 8 can't go into 1.
2.
It's 8. Can 8 go into 8?
Yes.
Can 1 go into 8?
Yes.
Is that the smallest one that they can both go into?
Yes.
Yeah. So we need to change this 1 to equal 8. What do I have to do to it? Multiply it by what? Multiply it by 8. So times 8 times 8, it equals 8 over 8. Does that still equal 1? If I had 8 pieces in here, so 1, 2, 3, 4, 5, 6, 7, 8. Are 8 out of 8 colored in?
Yes.
Yeah, so it still equals 1 whole. It's just written differently. So now which one's bigger? 6 out of 8 or 8 out of 8? 8 over 8. So I want to say less than, so I'm going to use my less than symbol. So far, so good?
Yeah.
Let's do one more together, and I'm going to have you guys do some on your own. 6 over 18 and 1/3. What's the least common multiple with 18 and 3? Let's do the ladder method together, since it's been a little while. What can I pull out of 18 and 3? I can't pull a 6 out. What can I pull out?
2, 3.
A 3. What's 18 divided by 3?
1.
6. What's 3 divided by 3? 1. Can I pull anything else out right here?
Yes.
No, you can't pull anything out of 6 and 1. So we're going to make our L and multiply. What's 3 times 6?
18.
What's 18 times 1? 18. So we need to change both of our denominators to 18. Do I need to change this fraction? Do I need to change this one?
Yes.
Yeah, 3 times what gives you 18?
6.
6. We need to do times 6, times 6, and we get 6 over 18. So what symbol are we going to put in here? Equal. I'm thinking we need to do one more together. Let's do the one right below it.
Oh.
No, let's not. Let's do...
10 over 3.
You guys want to do this? Oh, that one's easy, though. They both have the same denominator already, so which one's bigger?
10 over 3.
10 over 3. That's an easy one. You don't have to change anything. Let's do this one over here. So 16 and 4. What's the smallest number that both 16 and 4 can go into evenly? Victoria? No. Least common multiple. That's the greatest common factor. I want the least common multiple. If I do 16 and 4 in the ladder method, what can I pull out?
4.
A 4. And I'm left with 4 and 1. Can I pull anything out of 4 and 1?
No.
No, so I'm going to make my L. Multiply. What's 4 times 4?
8.
16 times 1? 16. 16 is your least common multiple. Do I need to change this fraction? Do I need to change this one? Yeah, I need to do times 4 times 4. And it equals what? 8 over 16. So what symbol am I going to put in here? Sarah? you're going to put your less than symbol. So I want you guys do some on your own. If you cannot find the least common multiple on your own, do the ladder method. This will always find your least common multiple, which is also your least common denominator, if you do the ladder method. Okay, make your L, that's the number that you need to change your denominator to. Okay, go ahead and work for a few minutes.